Rolle's theorem and the mean value theorem. Two classic theorems in the study of mathematics. They both deal with the inspection of an extrema. We're looking this particular chapter at functions, and we are trying to analyze the graph to be able to determine if certain functions have relative maximum, relative minimums that we call extrema. Rolle's theorem, the first theorem here mentioned, is what we called in the study of mathematics an existence theorem. That simply means that the theorem is able to tell us that something exists. Now, in terms of how to get it, that's another question for another time. But the theorem here, Rolle's theorem, in the classification of existence theorems, gives us valuable information about certain functions. The next theorem, the mean value theorem, takes the end part of Rolle's theorem and says that since we have determined that a certain extrema exists, the mean value theorem says here's one way to get it. Well, let's first begin with Rolle's theorem. He has two important predicates as he starts. Let f be a continuous function on a closed interval ab, and that also let f be differentiable on an open interval from ab. So those are the two very strong predicates in our, as we call, the build of the theorem. Well, if that be the case, then he says that if f of a is equal to f of b, then there is at least one number in C. There's one number C in AB, such that f prime of C is equal to 0. And there's a graph of that here that you see where the number A and the number B, x equal to A, x equal to B. And so f of A is equal to f of B. If the function is continuous, that means it has no jumps, it has no holes, and it's differentiable. That means it has no spike. Over here, for the second graph, the function is continuous, but it's not differentiable. It's not differentiable here at this point x equal to c because you have a spike there. Differentiability is another way of saying smoothness for the curve, right? So here the first graph is smooth, f of a equal to f of b, f is continuous, f is differentiable on the one continuous on the closed interval, differentiable on the open interval, thus guaranteeing the result of Rolle's theorem, where he says that basically if you have the predicates, that the function will either top out or it will minimize. And so f prime of 0, what does that mean? If you go back and look at what's stated in the theorem, f prime of 0 equal to f prime of c equal to 0, simply means that the function will have a horizontal tangent. A very strong conclusion for any notion in mathematics. So let us see if we can make that happen. In these following exercises, determine whether Rolle's theorem can be applied to f on the closed interval. So two things you're checking for. You're checking to see that, make sure that f is continuous on the closed interval and that f is differentiable on the open interval. And if that be the case, then we look to find a c on the open interval from AB such that f prime of c equal to 0. Well, let's consider this problem. And notice here that f is indeed continuous. F is continuous. Here it's continuous on the open interval. It's continuous on the closed interval, from AB, and it's differentiable on the open interval. Oh, it's been a while. The devil is Very smart. F is continuous on the closed interval AB. And notice here that F is differentiable. This is a smooth parabola, and F is differentiable here on the open interval from AB. So we conclude that this implies, or therefore, there exists a C on the open interval from AB. Here AB is from 0 to 3, excuse me. Such that, or that guarantees, such that F prime of C is equal to 0. Can you find such a C? So here we set F prime of X. We'll set that equal to 0, but let's solve for it. This is negative 2X plus 3. We set that equal to 0. That implies that X is equal to negative 3 divided by negative 2. So X is equal to 3/2. Is 3/2, that is 1.5. Is that on the interval? It has to be on the open interval. Is that on the open interval from 0 to 3? Well, you better believe it is, right? So put a check there, and so we say that C is indeed 3/2. The next one, this function is a parabola, not a parabola, excuse me, it's a polynomial. Get my P's mixed up. It's a third degree polynomial, so it indeed is continuous. Since F is a third degree polynomial, here this implies that F is indeed continuous on the closed interval from negative 2 to 4, and F is differentiable on the open interval from negative 2 to 4. Then here by Rolle's theorem, there exists a C on the open interval from negative 2 to 4, such that F prime of C is equal to 0. So now we find such C. So we take the derivative, F prime of X. We use the product rule. The derivative here is the derivative of the first times the second. So the derivative of the first is 1 times the second, X plus 2 to be squared, plus the first, X minus 4, times the derivative of the second. That's 2 times the expression X plus 2 times the derivative of X plus 2, which is just 1. So we simplify this. Looks like we can factor out X plus 2. So we do that. We have here left X plus 2 plus 2 times X minus 4. So F prime of X is equal to X plus 2 times X plus 2 plus 2X minus 8. So we get X plus 2, and this is 3X minus 6. Just factor out a 3. So this is 3 times x plus 2 times x minus 2. We set that equal to 0. This implies that we have x equal to -2 and x equal to 2. Now the number c, or c's, would have to exist on the open interval from -2 to 4. Well, -2 is not on the open interval from -2 to 4, but 2 is. Since x equal to -2, it's not on the interval from -2 to 4. C is equal to 2, which is on the open interval from -2 to 4. We pick the other one. Okay, next we look at this problem. Now, it's a fraction. It's a rational function. So notice here that x is not continuous at x equal to -2. Right. But x equal to -2 is not on the interval of here that's given. But yes, x equal to -2 is not on the, has to be on the open interval. It's not on the open interval from -1 to 3. X is differentiable on the interval. So also f is differentiable here. Differentiability is on the open interval. So f is differentiable. So f is not continuous at x equal to -2, but x equal to is not on the open interval. So here f is continuous and it's differentiable on the interval from -1 to 3. So also f is differentiable on this interval. F is continuous on the closed interval from -1 to 3. Thus, Rolle's theorem is satisfied. So, there does exist a C on the open interval from -1 to 3, such that f prime of C is supposed to give us 0. Let's see. So we take the derivative f prime of x is equal to the derivative of the numerator, which is 2x minus 2, times our denominator, x plus 2, minus the numerator, put that in parentheses, times the derivative of our denominator, which is 1, all over our denominator, yes, to be squared. We simplify that. So this gives us, let's FOIL this out. So this is 2x squared We get 4x minus 2, so that gives us plus 2x minus 4 minus x squared plus 2x plus 3, and that's all over the x plus 2 to be squared. Simplify that, that gives us x squared plus 4x minus 1 all over x plus 2 to be squared. Now we set f prime equal to 0. F prime of x equal to 0 implies that x squared plus 4x minus 1 all over x plus 2 to be squared is equal to 0. Multiply both sides by the denominator, so you end up with x squared plus 4x minus 1 is equal to 0. Using the quadratic formula, this implies that x is equal to negative 4 plus or minus the square root of that 4 squared. We get 16 minus 4 times a times c, that's minus 4 times the negative 1, all over 2 times a, 2 times 1. So we get negative 4 plus or minus the square root of 16 plus 4, that's 20, all over 2. So we get negative 4 plus or minus 2 times the square root of 5, all over 2. That gives us negative 2 plus or minus the square root of 5. Now you check on your calculator to see exactly what those numbers are, but you'll notice x equal to negative 2 minus the square root of 5 is not on the open interval from negative 1 to 3. This guy is not an element. It's not on the interval from negative 1 to 3. However, x equal to negative 2 plus the square root of 5 is an element on the interval from negative 1 to 3. So the number c that you want is the negative 2 plus the square root of 5. Thank you.